Hello, welcome to another edition of Flip Notes. So today we're going to be talking about rational functions, and I will say I'm going to be honest with you guys. Has not been a pretty popular section, but it's a very valuable skill, being able to simplify whatever, no matter what it looks like. So let's just start off with a little warm up, and I'll try this in class if we're doing this in class together. Um, I would try this as you guys do this as a warm up, but um, you guys could do whatever you want at this point. So as a warm up, pause it, try it. But otherwise, let's go ahead and get started. So we guys call this reducing, but really the idea behind this is simplifying. So what we're looking for is common factors. Okay. So what are the common factors with 6 and 9? Well, go ahead and list them out. 6 is 2 times 3, and 9 is 3 times 3. And if you look, there's a common factor of 3 between both of these. And what we're doing here is that, you guys use the terms canceling out, but we're actually just dividing. It's just 3 divided by 3, which is 1, which is why 6 over 9 reduces to 2/3, or simplified to 2/3. If we look at number 2, it's the exact same idea. 2 times 3 times x, and this is 3 times 3 times x. And if we're looking at what's common, we have a 3 and an x. These are common factors, so we can go ahead and divide. X divided by x is 1, 3 divided by 3 is 1, and again we're left with 2/3. Okay, over here, 36. Now we can just kind of divide it into common factors here. So instead of breaking up 36 to a product of all of its primes, instead we're just going to do 18 times 2 times x, that's in the numerator, and then 2 times x in the denominator. And again, if we are dividing, right, again, you guys call it canceling, but if we're dividing, it's 2 divided by 2, which is 1, and x divided by x, which is 1. So now there's not a 0 on the bottom, there's just a 1 in the denominator, and this becomes 18x over 1, or just 18x. Okay, next, same idea over here. 5, there's nothing I could do there. It's 5 times x. And 40, again, I'm going to just kind of get the common factor here. So that's 8 times 5 times x squared. And again, what's common? 5 and x. But some students, they just want to bring the numerator or denominator up to the top. You cannot do that, right? So it's just 5 divided by 5 and x divided by x, which means my numerator is 1. So the completely correct simplified reduced expression is 1 over 8x squared. Okay. So now these same ideas, you guys probably whipped through that in 30 seconds, but I want to explain it for some of the people who maybe don't understand factoring that well, or common factors that well. But these ideas are going to apply down here, except down here we got to do a little bit more work, just a little bit more work. So this is why I said factoring is so important. So the first thing we're going to do here is factor, if possible, and then look for common factors, and then simplify. All right, so let's try this out. And these are really the same 3 steps here can be used for most of what we're talking about today. So let's factor first. So x squared minus x minus 12, well, that's x minus 4 and x plus 3. And x squared minus 16, that's x minus 4 with x minus 4. And again, we're looking for common factors. So there's a common factor of x minus 4 with one of those x minus 4s, and we're left with x plus 3 over x minus 4. And this is, again, a common mistake that students make, is they want to cancel out the x's. You can never, ever, ever do that. This is a term or expression that cannot be broken apart. And if you want a proof for that, just let x be any number, right? Just try it out. So now the top becomes 4, and the bottom becomes -3. Can you cancel 4 and -3? No way. You can never do that. So you can't cancel or reduce any of these terms. You cannot separate them. So this is the complete 100% correct answer. Okay. Now over here, x plus 4 over, this becomes, again, factoring out two numbers whose product is negative 24, whose sum is negative 2. So that's x minus 6 times x plus 4. And, sometimes we get into this false sense like, oh, it always has to work out. It doesn't always have to work out. But in this case, yes, there is a common factor here of x plus 4 with x plus 4. And x plus 4 divided by x plus 4 is just 1. So now this is 1 over x minus 6. Okay, and then here, this next problem, we don't have anything to factor, but we do have common factors, that's for sure. And this kind of resembles what we did in the top part there. So 48 is just 6 times 8, and that's over 8. X to the ninth, well, that's x to the fourth times x to the fifth over x to the fourth. Y to the third, okay, well, that's y to the third over y to the third times y to the sixth. And then z squared, and z, well, that's z squared is just z times z, and z is just z. So now, I'm color coding it so you guys could clearly see the factors here. So 8 with 8, that's 8 divided by 8 is 1. X to the fourth divided by x to the fourth is 1. Y to the third divided by y to the third is 1. And z divided by z is 1. And now let's look at what's remaining. We have a 6 times x to the fifth z in the numerator all over y to the sixth in the denominator. All right, so if we break it up to common factors, it's really easy to handle this. Okay, so let's do the same idea here. The same exact things, these steps over here apply. All right, factor, if possible, look for common factors, and simplify. Right, so even though it says multiplication, you would be in a world of hurt if you actually multiplied all these together and all these together. It would just be a huge mess. So even though it says multiplication, just kind of ignore that step right now. Let's look for common factors. And in fact, what's nice about multiplication is that once I factor it, I can rewrite it all under one fraction bar. So 5x minus 10 is 5, parentheses, x minus 2. And instead of having the multiplication symbol there, I'm just going to extend it because, as we know, when you have multiplication, you can write parentheses next to each other. That also means multiplication. So this becomes x, two numbers whose product is negative 6, whose sum is 1. Okay, well, that's going to be x minus 3, or x plus 3, and x minus 2. Now, in the denominator, I am going to kind of skip a step here. 7 times x minus 4, I'm going to rewrite this as 7 times x minus 2. I'm just moving it over here. There's nothing wrong with doing that. You're allowed to rearrange it any way you like. And then x squared plus 6x minus 16, that just becomes x minus 2 and x plus 8. So now let's look for common factors. We have an x minus 2 and another x minus 2. We have an x minus 2 and another x minus 2. So those are common factors. 5 and 7, nothing we can do about that. And x plus 3 and x plus 8, nothing we can do about that. So this just becomes 5 times x plus 3 all over 7 times x plus 8. You could distribute, but in reality, this is the correct simplified form. And that's what Math Excel would want as well. Okay, over here, I know that over here we factored, in this problem here, we factored and we simplified. Here, I actually am going to multiply. I think it does make it easier instead of simplifying and then simplifying again. So now, again, let's look for common factors here, or common terms, x to the ninth and x to the third, y to the sixth and y, x to the fifth and x to the fourth. Okay, so all I'm going to do is multiply these terms out with one common fraction bar, and I'm going to get 6 x to the 12th, y to the 7th, over 18 x to the 9th, y to the 3rd. And again, some of you guys will have your own techniques and strategies, and that's fine, but I know that there's some people that struggle on this, and so just follow along, and let's rewrite things with common terms. So 6 is actually a factor of 18, so I don't have to rewrite 6. X to the 12th, well, that's just x to the 9th times x to the 3rd. And y to the 7th, well, that's just y to the 3rd times y to the 4th. And I just kind of purposely rewrote it like this So we could see the common factors. 18, that's 3 times 6, x to the ninth, y to the third. And now look at your common factors. I have a y to the ninth with a y to the ninth. I have a 6 with a 6. I have a y to the third with a y to the third. And so all I do is I reduce or divide these common factors. 6 divided by 6 is 1. X to the ninth divided by x to the ninth is 1. And y to the third divided by y to the third is 1. And what's remaining is x to the third, y to the fourth, all over 3. Now you may ask, how do you know when you're done? Well, you're finished when there's no common factors. And if I look here, there's no other factors of x, no other factors of y, no other factors of 3. Okay. All right, so now uh, we're going to go ahead and I know it says division here. And again, if you were to try to just divide and multiply, because some of you guys know that strategy, you would end up in a world of hurt here, okay? So it doesn't matter really the order, factor first or flip first, but we know that when it's division, we should rewrite it, and I'm going to do that for this problem. I'm going to rewrite it as multiplication times the reciprocal. Okay, so all I did is I rewrote it, and now I go ahead and I do the exact same thing as I was doing before. Okay, I start factoring. Okay, so two numbers whose product is negative 20, whose sum is 8. So that's x plus 10 and x minus 2. Okay, and then 20x cubed stays as 20x cubed. Nothing I could do there. And then x squared minus 2x minus 8, that becomes x minus 4 and x plus 2. Okay, and hopefully you see that you could do more here. Okay, so I'm going to, again, these problems take a little while, so don't think you're going to be able to do it in your head and come up with an answer right away. It's okay to struggle and show your work and write. That's all part of the fun of mathematics here. Okay, so I'm just rewriting this. And now we're going to look for common factors. Okay, so I have an x plus 2 with an x plus 2, and that's it. So I know that sometimes we expect more things. I have a 4 that goes into 25 times, okay? But this is if this is all you can do, then this is all you can do. Okay? Don't think that the answer has to be completely simplified. So I'm going to rewrite it a little simpler as x minus 2 squared times x plus 10 all over 5x cubed times x minus 4. And that is the 100% perfect answer. You really can't go any further than that, okay? So again, one more time here. This time, for fun, I'm just going to factor first. Again, that part doesn't matter, but what does matter is if you notice this division, you can't just start, multiplying out or canceling things out, right? So this time around, I'm going to factor first. So x plus 9 divided by, okay, x plus 9 times x minus 1 all over x plus 4 times x minus 1. And then here, for some reason, it doesn't always work out, but you do have a common factor. Let's just go ahead and rewrite it. Let's not get too excited. So I'm going to rewrite this as multiplication. So that's x plus 9 times, when I flip it, x plus 4 times x minus 1 all over x plus 9 times x minus 1. Okay, this is now your multiplication problem. And I look for common factors, x minus 1 with x minus 1, x plus 9 with x plus 9. And, when you divide, it's a 1 in the denominator, so now the answer is just x plus 4 over 1, or just x plus 4. Okay. All right, so now multiplication and division is actually a little bit easier than addition and subtraction. And the reason being is that some of us, we forgot how to add and subtract fractions. So we got to make sure that you can only add or subtract, with a common denominator, with the same common denominator. Okay, So they have to be, your denominators have to be the same. So if we look at this first problem, it's 8x and 8x. We're in great shape. So the nice thing when you have the same common denominator, or the same denominator, is that you can just rewrite it under one denominator and just carefully simplify or rewrite it and carefully simplify to combine your like terms. So my like terms are x with 3x and 5, negative 5 and 7. And so now I'm left with 4x plus 2 all over 8x and um, and then now hopefully you notice that there is a factor of 2 in each of these. So this becomes 2 parentheses x plus 1 all over 8x. And the reason why I'm able to do that this time around is 2 divided by 8. That's 1 over 4. So this becomes x plus 1 over 4x. Don't, 2x plus 1, sorry. 2x plus 1 over 4x. Don't even think about canceling out these x's. It does not work that way. You cannot do that. Okay? You cannot just cancel out those x's. They are not. There's not like terms. Again, this is a term. This is an expression on top that cannot be separated. Okay. Same thing here with subtraction. The reason why I did it like this long way here is because of subtraction. Yes, addition, I know that a lot of guys could just do this in your head, but over here, when it's subtraction, you cannot forget that minus sign there in the middle. So 9x plus 10 over 10x minus 60, okay, they are the same denominators, so it's okay to rewrite it, minus 5x plus 34. There's going to be a lot of students that are not going to they're going to forget about this negative sign, and then you're just going to do minus 5x, but you're going to forget about the 34. So now as I rewrite this, I get 9x plus 10 minus 5x minus 34 all over 10x minus 60. I combine my like terms here. So 9x minus 5x is 4x. 10 minus 34 is negative 24 all over 10x minus 60. And, sometimes students are like, well, how far should you go? You got to go until there's no other common factors. So look for stuff that are common. For instance, 4 and 24. I know I can factor out a 4 from this. I'm left with x minus 6. Okay, 10x and 60. I know that there's a factor of 10 there, and I'm left with x minus 6. Okay, and now hopefully you see this, x minus 6 with x minus 6, and even 4 and 10, because there's a common factor of 2 there. So the 100% completely simplified answer is going to be 2/5. Okay, but now if we look at these next few problems, we notice that there is not a common factor. Okay, so x squared minus 49 and x minus 7. Okay, 8x to the 5th and 3x to the 3rd. Okay, these two are not the same. So hopefully we have the wherewithal to know, hey, I got a factor and I got to look at what's missing. Okay, so think about this problem here. If I have 2/3 plus, let's go with over 7/6. Okay, if we're going to add these together, I need to make sure I get a common denominator of 6. Okay, or common factor or common denominator of 6. So now what I'm going to do is I'm going to multiply 2/3 by 2 over 2, because 2 times 3 is 6. And now this gives me 4/6 plus 7/6, which is 11/6. That's how I can do it. So if I look at what's missing here, 4x over x minus 7 plus x over x minus 7 times x plus 7. I notice that there's an extra factor here of x plus 7. Well, that's what's missing over here. In order for me to combine these, I got to multiply both numerator and denominator by x plus 7. Now, as a little cheat sheet, you kind of already know that it's going to be x squared minus 49. So I know for sure that that's going to be my common denominator. And so now this numerator becomes 4x squared plus 28x plus x. And again, I combine my like terms to get 4x squared plus 29x all over x squared minus 49. And that answer is perfectly correct in my book. There is common factors, but if you break it down, and so let's say we break it down completely, we get a common factor of x, so that's 4x plus 29. And here, I guess you could write it as x minus 7 times x plus 7. But you notice there's nothing else in common. There's no other common factors. Okay, so number 11, for some reason this also gives students some issues. So there's nothing common between 8 and 3. So that's like if we did this kind of problem, 2/3 plus, let's go with 4/7. There's nothing in common between 3 and 7. So the way I handle that is I multiply this by 7 and this by 3. And that's the quickest way to get a common multiple. Right? But now sometimes we want the least common multiple, so you got to look for something that they have in common. But this will always work as well. So this is 14 over 21 plus 12 over 21. And now I can add these together to get 26 over 21. Okay? Well, that's the same idea here. 8 and 3 don't have common factors, but the least common multiple between 8 and 3 is 24. And the way I could get that is by multiplying this by 3 and this by 8. However, there's more. This is x to the 5th, and this is x to the 3rd. So this is also missing two factors of x. So now I have to multiply that. Let me just rewrite it so it's a little bit neater. X plus 9 over 8x to the 5th minus x minus 4 over 3x cubed. And so these new common factors, this is multiplied by 3 over 3, and this would be multiplied by 8x squared over 8x squared. And now your denominator becomes 24x to the 5th. And this numerator, be careful here, becomes 3x plus 27 minus, okay, you get a minus sign to distribute to each term, minus 8x cubed plus 32x squared. Okay, so let's look at this and rewrite it in descending order. So this becomes 32, or actually 8 goes first. 8x cubed plus 32x squared plus 3x, negative 8x cubed, plus 32x squared plus 3x plus 27 all over 24x to the 5th. And there are no common factors, so that is your answer. Okay, over here, it's the same idea. So we got to factor first. So x plus 4 times x plus 5, and this is x plus 5 times x minus 3. So if we look at these, what's missing in each? Well, this denominator is missing the x minus 3, and this denominator is missing the x plus 4. So now I multiply this term by the missing term, which is x minus 3, this expression by x minus 3, and this expression by x plus 4. So my common denominator is going to be x plus 4 times x plus 5 times x minus 3. And my numerator, just for now, I'm just going to rewrite it. I'll do the work later. All right, so now you got to do a little bit of the work here. This becomes x squared minus 5x plus 6 plus 4x squared plus 16x all over x plus 4 times x plus 5 times x minus 3. And now I combine my like terms, 5x squared plus 11x plus 6 all over x plus 4, x plus 5, and x minus 3. Now you could try factoring in the numerator and see if there's any common factors, but just take my word for it, there isn't. And this is your final answer. All right, so we're going to kind of pause right here. I'll break this up in, well, we can keep going. Okay, you guys need a mental pause. You pause. Okay, this next part is also sometimes a little tricky. And I've taught it a number of different ways over the years, but so far I think we've had the most luck by finding the common denominator. So sometimes what my students had struggled with in the past is, okay, well, let's see. 1 plus 1 over x. This is a strategy that worked for them. So these are the list of all the terms here. And now, okay, looking at 1 over x, 1, and negative 1 over x, what is your common denominator? Well, you could look at it, well, this is 1 over 1, and this is 1 over 1. But basically, what is the only thing you see in the denominator? Well, it's just the x. So the common denominator is x. And now the strategy here is once you identify your common denominator, that's like your first step. Okay, the next thing is you're going to multiply every term. And multiply every term by that common denominator. So I'm going to multiply everything by x. So this times x, this times x, this times x, and this times x. Okay, so now we get x plus 1, because this is x over x, all over x minus 1. Okay, so 1 times x is x, 1 over x times x is 1, 1 times x is x, and negative 1 over x times x is 1. Okay, and that's it. Hello, we're going to continue. I was gone, but for you guys, it's going to seem like it's just continuation. So this technique, again, my students said it helped them a lot. So all I'm doing is I am listing out, oops, I don't want that. I'm listing out all the factors. So 1, 4 over x minus 1, and 2. And what I want you guys to do is just kind of notice, what is the common denominator? Well, okay, 1 is really 1 over 1, and 2 is 2 over 1. So the common denominator here is x minus 1. And now what I'm going to do with this is I'm going to multiply every single term by x minus 1. So it's 1 times x minus 1, 4 over x minus 1 times x minus 1, and plus 2 times x minus 1. And because of this, we see that these will cancel or divided by each other, and you get 1. And so now, if you notice, we're not going to have any fractions other than the original fraction, which is one numerator and one denominator, because my numerator becomes x minus 1, and my denominator becomes 4 plus 2x minus 2. And after I combine like terms, I get my final answer as x minus 1 over 2x plus 2. Now I could factor a tiny bit. It's not going to change the answer too much, but x minus 1 over 2 times x plus 1, put them both in parentheses, and most likely that's going to be the 100% correct answer that Math Excel wants. Okay, so I'm going to keep on doing these. You guys should probably pause it and challenge yourselves here and see if you could get these. So again, this technique that worked for my students in the past is listing out all the terms and then looking at them and deciding like, oh, okay, well, what's the common denominator? Well, the common denominator is x, or 1x. You can multiply 1 times x, it's still x. And now to finish it, I'm going to multiply every single term by x. And what this allows me to do is to rewrite this with, instead of being a complex fraction, it's just being a regular fraction with one numerator and one denominator. So the numerator becomes negative 9 over x times x is just negative 9 plus 2x. And once you see it, you'll be like, oh, it's really not that bad. But when we've taught this in the past, a lot of students have trouble seeing what the denominators are. So again, here's my technique that should help. 2, 3 over x, 1/2, 1 over x. All right, and now, what's my common denominator? Well, this is 2 over 1, and so if I look at my denominator, I have a 1, I have an x, I have a 2, and I have an x. Since it's just x and not x squared, that means my common denominator is 2x. Okay, and I'm going to rewrite it down here so it's not so sloppy. and I'm going to multiply every single term by 2x. And again, by doing this, it allows me to write it as a single numerator and a single denominator. So 2x times 2 is 4x, and then 3 over x times 2x, these x's, they cancel out to divide each other out, so it's plus 6 over 1/2 times 2x is just x, minus 1 over x times 2x is just minus 2. And, you could go a little further. You could say that this is 2 times 2x plus 3 over x minus 2. And that's as much as you can do. This is the final 100% correct answer. Okay, there's a couple more, and you'll see like it's not too bad. There's not too much more than this. And again, this technique of listing it off to the side. So 5, 3 over x minus 4, and 1. And again, I'm going to put this over 1 and this over 1. So what do you see? What's your denominators? Well, you got 1, you got x minus 4, and you got 1. So that means your common denominator is x minus 4. Okay, so I'm going to multiply every single term by x minus 4. So 5 times x minus 4. 3 over x minus 4 times x minus 4 plus 1 times x minus 4. And after a little bit of simplification, we get 5x minus 20. These cancel, right? 3 plus x minus 4, which gives me 5 times, I'm going to simplify this, 5 times x minus 4 all over x minus 1. So again, you could, you could do it a different way if you want, but I found over the years that kids like to do it this way. Okay. Oh, the different colors here? Oh yeah, look at that. We have different colors. Okay, let's do it again. So again, 8 over 5x, 7 over 5x, 2. So I look at my denominators. I have a 5x, I have a 5x, and this is really 2 over 1. So it's a 5x, and a 1, which means my common denominator is just 5x. So I'm going to multiply everything by 5x. So this times 5x, this times 5x, and this times 5x. So 8 over 5x times 5x, that's just 8. 7 over 5x times 5x, that's just 7. And 2 times 5x is 10x. And there is nothing else to do there. All right. So now let's say you're good so far. You're like, oh yeah, I totally got this. And then you look at these and you're like, I don't know if I got this. Yeah, you do. You got this. It's the same thing. 9 x plus 8 over x. 4 x minus 8 over x plus 8. So again, remember, this is a factor. You can't just say, well, like, oh, that's just an x with an 8 added to it. I'm like, no, it's not. It's x plus 8. There's a whole new factor. So you have 9 over 1, we have 4 over 1, we have x, and we have x plus 8. So in a count of 3, tell me what the common denominator is. 1, 2, 3. X times x plus 8. Yes, hopefully you guys said that at the same time as I did. That means that you totally get it. So yes, we have an x and we have an x plus 8. These are two different things. So now, again, this is why I have so much room here. Now I'm going to rewrite this nice and neat as I possibly can. And I'm going to multiply every term by x times x plus 8. X times x plus 8, x times x plus 8, x times x plus 8. So it works out pretty well with like the ones that have the terms in the denominator, like the x or the x plus 8. But yeah, I mean, you got to do a little bit of work here. But this is college algebra. You got to do a little bit of work at college algebra. So I could probably skip a step here and say that this is 9x squared plus 72x. But over here, I'm not going to skip a step. It's going to be minus, and then x plus 8 times x plus 8 is x squared plus 16x plus 64 all over, and I can do it here, so this is x squared plus 8x, so this becomes 4x squared plus 32x plus, and this is just x squared minus 8x. I gotta distribute. Okay, take a deep breath, and let's just finish this up. So 9x squared plus 72x minus x squared minus 16x minus 64 all over 4x squared plus 32x plus x squared minus 8x. And now I'm going to combine my like terms. It's going to be kind of a big problem here. So this is 8x squared plus 72x minus 16x. So 72 minus 16, 56x minus 64 all over 5x squared, okay, 32x minus 8x, okay, that is minus 20 or plus 24x. And now there is a tiny bit of cleaning up we could do, okay? We could factor out an 8 from each of these terms, so that becomes 8 times x squared plus 7x minus 8. And then we could factor out an x from each of these terms, and that becomes 5x plus 24. And then, you could go a little further on top. I mean, this answer is pretty good, but you can go a little further, right? So two numbers whose product is -8 and whose sum is 7. So you could say it's x plus 8 and x minus 1 all over x times 5x plus 24. Okay, so these problems are definitely not for the faint of heart, but you need to build your math stamina, and this is a good way to do it. Okay, just kind of you keep working, you keep changing it, you keep going until there's nowhere else to go, until there's no common factors. All right, last one here. Okay, so again, here are my terms. X plus 5 over x minus 4, comma, x minus 3 over x plus 2, comma, x plus 2 over 1. And what is my common denominator? Again, on a count of 3, shout it out. 1, 2, 3. X minus 4, x plus 2. Okay, good. Hopefully you guys all said that, because that's what it is. There's nothing else going on down there. And now I am going to multiply every single term times, or by, x minus 4 times x plus 2. So I'm going to rewrite this, because it's going to get pretty big. And x minus 4 times x plus 2, x minus 4 times x plus 2, and x minus 4 times x plus 2. Okay, and now this is going to work out, even though it looks bad, it's going to work out pretty nice. Those are gone, those are gone, and now I have x plus 2 times x plus 5 minus x minus 3 times x minus 4 all over, don't bother multiplying that out, that's crazy. Let's just leave it in factored form. X minus 4 times x plus 2 squared. And simplifying a tiny bit, it's not as bad as the last one. This becomes x squared plus 7x plus 10 minus, I'm not going to skip a step, x squared minus 7x plus 12. And all your hard work's going to pay off in a second, because when you distribute it, you get kind of a nice thing. You get rid of the x squared terms. Okay, so I'm just going to recopy this. And if you look at this, we have opposites. We have x squared and we have negative x squared. So they're going to eliminate each other. And my absolute 100% final correct answer is 14x, 7x and 7x, minus 2 all over x minus 4 times x plus 2 squared, and could go a little further if you wanted to. Take out a common factor of 2, and I have 7x minus 1 all over x minus 4 times x plus 2 squared. Okay. All right, so that was it. Okay, and we'll see you guys. This will be for notes for due on Friday/Monday.